So Lavan, please let me know if you wanna leave. Lavan, are you there? Okay, guys. So the telecommunication system, if you remember, we said that we're gonna focus on how we can how the data move from sender to a receiver. And when we said telecommunication, we mean that it's a far, all right, it's a far distance. So that means the data need to travel for a long distance from transmitter to receiver, or from node to nodes, or whatever type of communication. So this one actually we call it communication system. And the telecommunication systems, we focused on the how the data will be moved from here to here. All right, so we said we have wired and wireless. All right, we have wired and wireless. In wired, we have done circuit switching and packet switching. All right, so now we are in wireless. All right, we are in wireless to move the data from this one to this one, from node to node. Okay, so we said that we will start from, we will focus 3G onward. All right, 3G, 4G, and 5G. For sure, actually 6G now the research is active. All right, 6G is active. So we'll try, brief about the second generation, 2.5G and 3G. In 3G also we have 3 and 3.9, but the most popular one is 4. All right, it's not 3.9, it's 4. So let's try, by today to have a very fast introduction about these technologies. All right, so starting, let's say, from second generation, 2G second generation standards. It was we have two standards. All right, the TDMA and CDMA. All right, so TDMA actually is the multiple access, time division multiple access. All right, so what do you mean by multiple access? And we have another standard, we call it code division multiple access standard. So any idea about multiple access, guys? Let me ask some of you, especially those who done their internship. Mardin, do you have any idea about multiple access? Zaniar Khalil. Zaniar Khalil. Faiz, do you have any idea about multiple access?
Sir?
Yes.
Isn't it the method that permits various terminals to connect to the same multi-point transmission medium, so it can transmit over it and share its capacity?
Yeah, exactly. Shared its capacity. Yeah, the last one. It's perfect. Yeah. All right. So when we said multiple access, guys, normally the spectrum, as I mentioned, if you remember last class, when we discussed about the regional area network, we said that the spectrum actually is natural resources and is limited. All right, so it's limited. So this is the spectrum, all right, which is very very limited. And here we have a huge number of subscribers. For example, let's say in the Hawk we have, let's say 1.1 million subscriber. I'm not sure, but maybe. All right, 1.1 million subscriber would like to access this limited spectrum. So it's really difficult. All right, it's really difficult. So the RF engineer proposed what you call the multiple access. It's the way to share the capacity, is the way to arrange the access of subscriber to the limited resources, which is spectrum. So this is the multiple access actually. So when we said TDMA, the way that the subscriber share the spectrum, it's by time. So that's why we call it time division multiple access. All right, and we have frequency division, for example, frequency division multiple access. We have orthogonal frequency division multiple access. So we have different type of multiple access, but the main idea of multiple access is to give the opportunity to huge number of subscriber to share limited capacity. Similar to our daily life, for example, if we have a class for the capacity for the class is for 10 students and we have 20 students. All right, we have 20 students. So how we can do that? Maybe we can divide it into 2 sessions. All right, from 9 to 10, session number 1, 10 students, and from 10:30 to 11:30, another group of students. All right, so exactly same. So this one actually started, for example, the standard for second generation, it was TDMA standard, and also we have what we call a CDMA, code division multiple access. So the time actually, as you know, it's per time. Okay, that means this one, the subscriber use same frequency, all right, same this one, but with different time. For example, time 1, user 1, time 2, user 10, and so on and so forth. All right, so this one actually, it was very well known as GSM. All right, Global System Mobile, GSM. And also we have some IS 136, or we call it interim standard. And also sometimes we call it USDC, which is North American Digital Cellular, and Pacific Digital Cellular, this one for Japanese standard. All right, so another standard, which is multiple access, we call it code division multiple access. This one actually is very interesting, multiple access. It's totally different from the time division, and also different from the frequency division multiple access. This one actually based on code. All right, based on code. What does it mean? So that means if we have, this is a limited, all right, limited resources, and we have a huge number of subscribers. So all subscribers can use the spectrum or the limited resources at the same time, and using same frequency, but each subscriber has its own code. Each subscriber has its own code. All right, so that means the design, the hardware design for this one is totally different from time division multiple access, and totally different from frequency division multiple access. And in this scenario, we have what you call it a code generator. All right, code generator, which is random. All right, random. For come this signal from user 1, will multiply with the unique code, and after that will goes to the modulation and to the to be available in this spectrum, to utilize some channel within the available spectrum. All right, so this one also similar to our daily life. For example, if we would like to simulate this one to our daily life, if we have, let's say, one venue or one room, and we have a group of people, let's say 15. All right, so this one we can divide it 5, 5, 5. All right, so we have 3 tables. Each tables comes with 5 people, and we ask them all together, 15, to communicate. So this group communicates with each other, this group communicate with each other, and this group communicate with each other. So if we ask them to communicate using English, all of them, all right, So this one, if we ask them 15 at the same time, so the interference will increase, because all of them, we assume that all of them can understand and can communicate using English. All right, so that means the interference will be really high. This group can communicate difficultly, and because this one, they can understand what this group talking about, and they can understand what this group talking about. So the interference will be increased, the noise will be very high. But if we have another scenario, we divided 3 groups. So this one, we ask them to communicate in English. And this one, we ask them to communicate in France. And this one, we ask them to communicate using Mandarin or Chinese. All right. So this group, for example, can communicate only using French. I mean, they cannot understand English and they cannot understand Mandarin. And this one also, they cannot understand this one and they cannot understand this one. And we ask all groups 1, 2, 3 to communicate at the same time. So this one, they communicate in English and they don't understand this one and they don't understand this one. So still they have a noise, but is limited compared to the previous one. All right, because this group has its own code and this group has its own code and this group has its own and unique code. So same, I mean, the idea comes from this scenario, and they goes to CDMA code division multiple access. They divided, I mean, they give the spectrum to be available to all subscribers at the same time and using same frequency. If you remember time division, we have same frequency, different time. But in frequency division, we have, I mean, each user has its own frequency, but same time, all right? But here, same time, same frequency for all, but each user has its own code, which is unique code, all right? So in this particular case, it's, I mean, we achieve the advantages of utilizing the whole spectrum, same frequency, same time, but with different code. And in this case, the efficiency will be really much higher compared to time division multiple access and even to frequency division multiple access. So this is the idea of this this standard CDMA, which is called code division multiple access. And we have another one, as we will see in the 3G, we have WCDMA, which is wideband code division multiple access. In this one, actually, we have two different techniques. Actually, one we call direct sequence, and the second one we call the frequency hopping. All right, in order to generate the code and for subscribers. So this one actually is normally used in normal mobile communication. That means we are currently using this one, for example, DS, which is direct sequence, and this one for military service, frequency hopping. This one actually comes with very high security, all right, because the user will, what we call frequency hopping, that means the frequency will hop, or the user will hop from one channel to another, all right, one channel to another. This is the spectrum. So currently I'm using F1, I said, hi, how are you? And after that, I move to frequency 2. What's going on? After that, I move to frequency 3. I need this one and that one. All right, so it's frequency hopping. Keep changing the frequency. So in military service, they use this one to provide high security. So if you catch me at this channel, you will listen, you will hear only hi, how are you? But after that, I will change, hop, I will hop. So it's very difficult to track. All right, it's very difficult to track. All right, so this one also they named as IS95, IS95A in term standard, and it is marketed under the brand name of CDMA1. All right, so CDMA1 standard under CDMA digital zero technology or wireless technology. All right. So as a history from 1G to 3G, so first generation, it was analog, pure analog, frequency division multiplexes, and in terms of multiplexing, frequency division multiplexing. And for second generation, introduce digital, all right, digital in terms of analog, and also it was introduced the SMS short message service. So we are still using this one, SMS. If you would like to text your friend using your credit, so this one will be SMS, short message service. All right. And this one, the most popular, as we said, is GSM. All right. So I mean, with the growth of the internet, they moved to what we call it 2.5G. But this one actually is not well known. Because in technology we said first generation, second generation, third generation, fourth generation, and the latest one is 5G. But in between we have some details. For example, from 2G to 3G we have 2.5, and from 3G to 4G we have 3.9. But this one actually is, I mean, it's not nice to say it's 3.9G. All right, that's so that's why they refer to 4G. All right, but we have some development which is not similar to 3G before we reach to 4G. Okay, and also similar to the second generation. We have some development and some contribution to the second generation, which is not similar to the original 2G. So that's why they refer to 2.5G instead. So one of the development of this one, in order to use them, I mean, provide some better data communication over the internet, they provide GPRS, which is General Packet Radio Service, which is another base station that provide internet to the users or subscribers. All right. All right. So improve the performance of second generation system using techniques such as this one, Edge. All right, Edge technique, which is enhanced data rate for GSM, and then introduce more powerful third generation system in the year of 2000. All right, so starting from that date, they launched 3G. All right, 3G. I mean, yeah, for example, yeah, some countries like Singapore, they started 2.0.1 or 2. All right, it was some, I mean, nice feature at that time. All right, so the second technology is circuit switched. All right, this one, circuit switching technique, the one that we have done it. All right, the one that we have done it. All right, I mean, when they communicate from mobile to what we call it PSTN. All right, so data modems that limit data user to a single circuit switch voice channel, which is too slow for rapid email and internet browsing applications. New data-centric standard required support higher data rate transmission for web, email, location-based mobile service. All right, so this one, mobile commerce, that means business over mobile, and this one location-based mobile. All right, so this one in 2003. In 2003, they provide friend finder. All right, friend finder, so you can text your mobile number for your friend and you can find him or her location exactly at this point, at this restaurant, at this cafe. All right, so the Japanese actually is the first country, because actually Japanese, they have their own standard, wireless standard. All right, Japanese, they have their own standard, and Chinese, they are developing their own standard to be, I mean, independent from Western. So they are working very hard toward I mean, implementing their own standard. This one, Docomo. All right, Docomo, which is do com over the mobile net. Introduced the data service and the internet micro browser technology, iMod. This one in 1998. All right, so 2.5, you can see now we are in 2G and 2.5G, which is somehow is different. All right, so high speed circuit switched data, which is HSCSD. for 2.5 GSM, and also GPRS, which is another features not initially produced by second generation. So that's why they call it 2.5. But I mean, commonly we use 2G, 3G, straightforward. But in between, they did really hard work in order to develop the wireless. All right, so this one actually, it's a high speed, it's a still circuit switch technique. So this one actually allows usage of consecutive time slots to obtain higher speed data access. All right, because the G actually is even starting from 1 until, let's say, we are in 5, all right, approaching 6th generation. That's in terms of data. So this one, the data like this, all right, and the voice is like this, dropping. So since the data is, the demand on data increasing again and again. So that's why we need to develop. All right. So we have another technique, which is, we call it enhanced data rate for GSM, which is EDGE for 2.5G GSM and interim standard 136, more advanced and new hardware and software at base station. So you can see this is the most important features. So since we said that some new hardware and software added to the previous one, so they call it 2.5. All right, they call it 2.5, but it's not up to the demand for third generation. And this one, the GPRS, is to provide better data communication over the second generation. All right, over the second generation. So you can see, for example, this one, second generation IS95, and this one GSM. So this is the Europe standard. All right, this one, the Europe standard, and this is the US. All right, so we have two common standard. So we have, the Japanese, we have the as I mentioned, the Chinese, previously the Scandinavian countries, they adopted their own standard, but currently we have the most common standards. The most common standard for wireless, either the European, or we call it, GSM, because it's very well known as the GSM, and US standard. All right, so moving to this one, 2.5G, you can see same, all right, but we have B, all right, and here we have the GPRS, the EDGE, and the HSC, SD, in order to improve the data, provide better connections for the subscribers over the data communications. And after that, they move to third generation, all right, they move to third generation. Here we have CDMA, code division multiple access, sorry, 2000. Single carrier radio something technologies, transmission technologies, and CDMA 2000 single carrier evolution, and for this one, data voice and data evolution and data and voice. All right, because we have two versions. And CDMA 2000, which is the third generation radio transmission technology, if I'm not mistaken, RTT or radio something technology. So this one for the US, and this one for the European, which is wide WCDMA, which is wideband code division multiple access, and this one, the EDGE technology, and the TD time division synchronous code division multiple access. So another type of multiple access. All right. So this one actually is very important, 3GPP, which is the third generation partnership project, 3GPP. It's actually a very nice website, so I really recommend you guys to browse that this site. All right, you can find really the history of wireless communication from even before first generation until the latest release. All right, the latest meeting minutes for the working group on 5G. So it's really very nice website, and you can find many white papers, all right, that explains the concepts of standards and the concepts of technologies that related to wireless. So this one actually is very important. So I really recommend you guys to have a look on and browse this website. Will be very nice. Give you, I mean, really nice nice knowledge on the development of wireless technologies. So you can download even the 5G technologies, the release 1, release 2, release, I mean, I think 17 now. All right, for 5G, 17.1 or 17.2, and all right, so explaining the development step by step. All right. And this one, 3GPP2, all right, which is, I mean, same here, 3rd generation partnership project. And this one, partnership project 2. This one you can see. This one is 3GPP2, and this one is 3GPP. So this one actually, the also you can I mean, check this website, but this website actually is not like this. This one is, I mean, very nice and really up to date, and everything's actually in proper. All right, so this one actually is highly recommended compared to this one. This one you can, I mean, you can see this one. You can click and you can see and you can discover, but it's not like the European. All right, it's not like this website, the 3GPP. All right. So for 3G, so this one we said, if you remember, 2nd G CDMA, which is IS95, evolves to CDMA 2000. So if you are talking, this one, number 1 is the US. All right, so the development in the US, and this one, the development when we said GSM, is Europe. All right, Europe. So we have US and we have Europe, because these, I mean, two systems, the dominant systems, I mean, recently. We are which one? We are here. All right, we are following this GSM. All right, most of the countries actually following the European system. Okay, so this one actually 2nd generation CDMA, which is IS interim standard 95. This one actually evolves to CDMA 2000, and the original 3G technology was known as CDMA 2000 1X, or single carrier radio transmission technology, RTT. All right, radio transmission technology. And this one enhanced to 3.5G system with 2 alternative names, CDMA 2000 evolution data optimized, this one, data optimized, or CDMA 2000 evolution data and voice. This one, we are here, data and voice and data optimized. So from here we move. You can see from here we move, but in between we have this one. All right, in between we have 2.5G, but again, only the specialized people or the people in area, they know about the track, I mean, the development steps. Okay. But here, when we explain, we said moving from 2nd generation. All right, moving from 2nd generation. We are not saying moving from 2.5. We are moving from here to here, but again and again in between, we have really some amazing job done in this transit area. All right, between 2nd and 3rd generation. And this one, as I mentioned, enhanced to 3.5G system. All right, so the specification for IS95 and CDMA 2000 are produced by a similar corporation to 3GPP, which is known as a 3GPP2. As I mentioned, this one or this one, you can refer to this one, but this one actually is the best, the websites compared to this. So this is for the US. For the on the other hand, for the European, this one GSM IS136 evolved to wideband code division multiple access, and also known as Universal Mobile Telecommunication Service, UMTS. But again, this one only for those specialized in telecommunication. They know about UMTS because, I mean, the European is very well known about GSM and CDMA. All right, but WCDMA actually is not, it's not friendly name. All right, wideband code division multiple access. I mean, only this one will be nice for engineers. So that's why they rename it to UMTS, which is Universal Mobile Telecommunication Service. All right. And two competing 3G standards, UMTS and CDMA 2000. UMTS is not, I mean, when you said this one, it's European. This one is the US one. The main difference, for example, here UMTS is not backward compatible with GSM, and CDMA is backward compatible with IS95, in the sense that this one mobile can communicate with CDMA base station and vice versa. While in this particular case, you have to change your mobile. All right, you have to change your mobile set, and also they need a new hardware component at the base station. All right, hardware component at the base station. So UMTS is not backward compatible with GSM. So that means 3G, if we are talking about in terms of G, cannot communicate with 2G. While in the US, it's a backward compatible. All right. So, but in this particular, you have to change your, if you'd like to, I mean, reach out the features of 3G, you have to change your mobile, and you have, all right, to what you call it, even the base station. The telecommunication companies, they need to change the hardware, all right, the frequencies, the power, I mean, everything. So they need to change in order to allow people to communicate using 3G technologies. So this is the main features, the main differences between what you call it, the US standard and the European standard. All right. Yeah, so this one actually, you can reach to this CDMA developers groups, and you can reach to this one 3G partnership project for WCDMA standard, 7 organizational partners, Asia, Europe, and North America, and 3G PP2 3G partnership project for CDMA 2000 standard. All right, so these are the sources. It's very important. You can discover, you can read, and you can what you call it, develop your knowledge on this area. All right, so 3G WCDMA or UMTS, all right, Universal Mobile Telecommunication Service. What's that? Telecommunication Service, yes. All right, so this one submitted by European Telecommunication Standard Institute, ETSI, to IMT, International Mobile Telecommunication 2000 body in 1998. You can see, and for the reason why, as I mentioned, better data rate, and you can see here is supported voice call to be supported on a single 5 megahertz. So at that time, it was really amazing, 5 megahertz. All right, so in 2001, the subscriber there, they were very happy in watching some short videos by using their phone. All right, so because we have, I mean, at that time it was really great band. All right, great band at that time. And for 3G CDMA 2000, developed under the auspices or under the care of the US Telecommunication Industry Association, this one, TIA, and use a channel bandwidth of 1.25 megahertz, and no need to change out RF equipment at base station. Changes are software or baseband hardware. That's it. So they save their cost. No need to change any RF equipment base station. While this one, as I mentioned, we need to change here. Yeah, so in third generation also we have what we call it a new multiple access. We call it time division synchronous code division multiple access. All right, is a derivative of this one, wideband code division multiple access, which also known as a low chip rates options for UMTS TTD mode, time division duplex mode. All right, so because we have frequency division FDD and we have TDD. So for FDD it's wide code division multiple access, and for TDD it's this one TD SCDMA. So as I mentioned, what you call it, the multiple access, actually we have details of multiple access, how the user can access and what are the frames and layers, and we have really, I mean, complicated and sophisticated technique in multiple access, but this is the idea of multiple access, generally speaking, the idea. All right, so yeah, this one actually is by Chinese. All right, Chinese. Yeah, to minimize the country's dependence on Western technology. All right, so they produce this one, and as I mentioned, they have their own plan, strategic plan to be really independent in terms of telecommunication systems. All right, in terms of telecommunication systems, so they're working very hard toward their own standards. And this one adopted by ITU. All right, so since adopted by ITU, which is International Telecommunication Union. All right, it's not related to Chinese, it's not related to anyone. It's an international telecommunication union which is adopted and approved this one as an amazing multiple access. All right, as an amazing and approved multiple access. So yeah. Okay, so this one, for example, WCDMA uses a wide band of 5 megahertz, while this one, it's almost similar to the US. It's a smaller value of 1.6 megahertz. You can see this one actually is 1.25 megahertz, and this one, like, I mean, close to the US in terms of the bandwidth, close to the US system or US standard. All right. So in terms of architecture review of UMTS, so this one, 3G. All right, 3G. And GSM, you can see here it's radio access network. We have GE RAN and UT RAN, and here we have in the core network, here we have CS domain, which is circuit switching domain, and here we have PS domain, which is packet switching domain. So now we are aware when we said circuit switching, you're aware about this one, and when we said packet switching, you are aware about this one. And this one will goes for the PSTN, which is public switch telephone network, and this one will goes to the servers, PDNs. All right, so there are 3 main components: core, radio, and mobile phone. So in 3 generation, this one we call it user equipment. All right, in 3 generation, as researchers in this area and engineers, they call it user equipment, no more mobile station. In 2nd generation, we call it MS, which is mobile station. But in 3G, they call it user equipment. All right, user equipment. And normally we are as a subscribers, we call it mobile. All right, we never call it where is my user equipment. All right, this one only for research purposes and for those who are the designer and specialized. So if you would like to publish a paper using 3G, for example, you can use UE. All right, it's not mobile station. All right, but generally in our daily life we call it mobile. All right, so the core network contains 2 domains: the circuit switched CS domain and the packet switched domain. All right, so this one is transport phone calls in the same way as a traditional fixed line telecommunication, or we call it landline, in which user can make calls to a landline via this one, PSTN. And this one transports data streams such as web page and email between users, external packet data network, this one, PDN, all right? Packet data network such as the internet, all right? So this is the architecture, UMTS and GSM. All right, so separate radio access, GSMH, this one, all right, GERAN, all right, which is GSM, GSM-Edge, which is radio access network, GSM Edge, you remember the Edge technology, enhanced data, which is, I mean, it was 2.5, so GSM Edge radio access network, we call it GRAN, and the UMTS radio access network, UTRAN. So this one, UMTS, all right, connected to this, and GSM connected to this, and connected to this, all right. And again, this one will be the mobile or user equipment, Yeah, this one, the device, user equipment, and normally we call it mobile, all right, normally we call it a mobile. All right, we call it mobile. We never call it as user equipment. Okay. All right. So the most important component at the base station. You can see in UMTS. All right, in UMTS, and previously in second generation, and we call it BS, which is base station. Until now, common name is base station, but official, I mean, in terms of research, those who are really expert, they call it node B. So if you are working in a company, all right, so the people inside that company, they should, I mean, normally refer to the base station as a node B, all right, node B, not base station. Actually, it's not wrong if you said it's a base station, but this is the official name, all right, for the for the third generation, node B, and this one node B. When you said node B, that means I can understand this one actually is a base station, which is same as this one, all right, same as this one in terms of second generation. But this one actually, in terms of power, in terms of frequency, in terms of hardware component, is totally different. So this one, not same this one, all right? In terms of frequency, in terms of band, in terms of power they produce, in terms of hardware component, this one is not the same. All right, so you can see here, I mean, we are really data dependent. All right, it's not voice. We are really on data, so that means you can see nowadays, I mean, Facebook and Instagram, Snapchat, and all that we use to most data. All right, so this one increased the availability of 3.5G communication technology. So that means the researchers sat down and the groups of 5 universities. Group of 5 universities at that time, I really can't remember, one from Sweden and one from US, one from UK, Bristol. I know Bristol because I mean the leading university in UK for 5G. And 2 remaining, I think one from Italy, if I'm not mistaken. I really can't remember, but I can remember only Bristol universities because one of the leading universities in developing wireless communication in the UK. They have their own lab equipment inside the university to develop wireless technologies. Anyway, and they discuss about the, I mean, developing. We are not, I mean, 3G, no more. I mean, efficient in order to provide the users demand on data. And this one comes with the introduction of iPhone. Now you are using iPhone in 2007. At that time, it was really amazing. all right, and after that Android operating system in 2008. So they said now we can move really ahead toward a new technologies. All right, but again and again we never heard about 3.5. Only those specialized, they know what happened in between. All right, they know what happened in between, or the journey from second generation to third generation, from 3G to 4G. All right. As a result, these issues, second and third generation, started to become congested in the year around 2010, leading to a requirement to increase network capacity. All right, so that's why they work very hard in order to provide some entertainment to the subscribers. All right, so you can see this this figure. Traffic. Well, you can see it's a comparison between voice and data. So you can see this one in 2007. All right, 2007, you can see the voice really amazing. All right, you are based on voice, we want to hear each other. But after that, you can see data. And this one, voice and data traffic in worldwide mobile telecommunication period from 11 to 16. You can see 11, data, more and more and more and more, and now even more. So what we need to do as a RF engineers, as a wireless engineers, so for sure we need to think in terms of developing and increasing the band again and again. So that's why there's some in 2004, I mean, this one starts, I mean, working and planning for the next. Okay, and the aim was to keep 3GPP mobile communication system competitive over timescales of 10 years and beyond, delivering the high data rate and low latencies in the futures. And this is the movement. All right, this is the movement from 3G to 4G. This one LTE. LTE is 4G. So we have different name, but the name that we know is 4G. All right, and sometimes some companies, they use LTE. All right, long-term evolution. So this is the system architecture, and this is the long-term evolution. All right, so from GSM and UMTS to LTE. All right, so here we have also some what we call it, development in between, in order to provide better data rate. And for example, here the development covered the radio access network, the air interface, and mobile. When we said air interface, is the what we call it, the communications between the devices, the way that's communicate. All right, the standard they use also should be changed. All right, so this one, official usage LTE, has become a colloquial name of the whole system, and it's regular use in this way by 3GPP. All right, LTE. Also after that, we call it 4G. All right, so this one, if you would like to talk about 4G, you remember 4G, we call it Node B, and now here we call it EMB. All right, EMB, E Node B, the base station, E Node B and E Node B. All right, this one, user equipment. So again, if you would like to do your own research, then you have to use this name. All right, it's not, for example, base station or whatever provided by previous Gs. All right, so this is the features. For example, data rate for UL and DL, uplink and downlink, and the latency, the coverage, All right, optimized cell size up to 5 kilometer, which is amazing for 4G, 5 kilometer instead of 1 to 3 kilometer previous. You know, it's performance up to 30 kilometer and support cell size up to 100 kilometers. All right, so this one actually in some really open area. All right, open area. And the speed, it's really provide high speed. And the bandwidth, you can see maximum of 1.4 to 20, and after that to 100. All right, so this is the key features of the air interface for WCDMA and LTE. You can see the multiple access technique here, WCDMA. Here is OFDMA and synchronous FDMA. So this one actually is one of the amazing multiple access or signal frequency division multiple access. This one actually is to reduce the interference. Reduce the interference because capacity increase again and again and again. So we need to think in terms of multiple access that really decrease the interference. And so these are all the air interface, the feature. All right, and okay. All right, so International Telecommunication Union launched a similar process in 2008 by publishing a set of requirements for fourth generation. Here, for example, in the late of 90s, had to drive a development of 3G technologies by publishing a set of requirements. Okay, they call it 2000 because they implemented in 2000, IMT 2000 and CDMA 2000. So because I mean initially they implemented in 2000 in the US and in the Europe, in the UK especially. All right, so this one in 2008, similar. We need to do what we are going to do in the upcoming years. 4G communication under the IMT advanced, and according to this requirement, the peak data rate, you can see 60 megabit per second for downlink and 270 for the uplink. For the bandwidth is 40 megahertz. Okay, and these are the requirements. LTE advanced, or we call it LTE-A. All right, from LTE to LTE-A. We are still in, I mean, 4G, but we have different version before we reach to 5G. Before we reach to 5G. All right, and using total bandwidth of 100 megahertz. All right, so this is for the 4G. All right, this is actually the planned one, all right, or the official released one, but you can see before these figures are unachievable in any realistic scenarios. So when we said it's 100 megahertz, or when we said this is the speed, actually we are approaching, all right, we are close but not. And this is actually normal in engineering design. What else in? All right, so the development of this one actually comes with the enhanced version to WiMAX. All right, you remember WiMAX, which is known as the WiMAX 2. All right, provides some more, I mean, better data rate and also better speed. You can see here is 3.9G. This is the one that so when engineers actually sat together and I mean, try to develop a third generation. So we reached to a point, they said that we need to name this one as a 3.9G. It's not 4G. We cannot say this one actually is 4G. But after that, they agree on 4G technology because, I mean, as I mentioned, this one is not much popular to community. Only we are, as a users, we know that first generation, second generation, third generation, fourth, and the next generation. All right. So when we said LTE, it's a 4G. All right, but you have to keep in your mind the development is we have, for example, 3.9G. All right, the wireless. This one, the development of wireless LAN. All right, development of wireless LAN and yeah. All right, so development of wireless LAN. You can see this one actually is a standard IEEE 802 dot. All right, so this one is standard for wireless LAN. 2.4, they, for example, this one is 2.4 gigahertz, the common one. This one direct sequence. All right, and this one frequency hopping. So direct sequence and frequency hopping. This one, the one that I explained previously, direct sequence is a normal code. All right, is a normal code multiplied with the input signal. So each user has a unique code. Frequency hopping, this one actually is for military purposes. All right, so that means the user hop from one frequency to another, keep hopping from one to another in order to be secure. All right, so this one actually is the modulation technique. All right, the modulation technique, all the modulation technique. All right, all the modulation technique. All right, personal, this one, I think. All right, so this is the, for example, personal area network. If you remember this one, we call it, for example, ad hoc. This one, this one, this one, and this one, this one. So we have connectivity. All right, so you can see, for example, here we have some common overlapping. What does it mean, overlapping? So that means if this laptop want to communicate with the printer, want to send some document to print out, they cannot reach directly. They need to communicate with this one because in the range, and this one will communicate with the printer. And same goes for this one. If you'd like to print from your mobile, all right, using your Wi-Fi printer, if you are in the range, then okay. If you are not in the range, then you can access, send, and reach the printer in order to print out. So this one actually example of what we call it ad hoc network. All right, ad hoc network. All right, so WiMAX forum, hotspot, and all this one actually is related to WiMAX. All right, WiMAX, this one. And yeah, this is the, for example, the range, the coverage area, Bluetooth, the ZigBee, and .16, which is the WiMAX. Yeah, this one .16 is WiMAX. And here we have some, for example, wide area network, which is for the CDMA, WCDMA, and 3G, all that stuff. And this one they're moving toward this one, the one that we explained the last class, which is wireless regional area network, which is 802.22 WRAN, which is, I mean, the interesting features, and they provide really very nice mobile communication and internet access to subscribers. So I think I will stop here for today's class, and see you next week. And next week we will have what you call it the midterm. All right, so please study hard for the midterm. The question will be not difficult. Some question will be from tutorial. I will upload some extra question related to in chapter 2. Ala asked me to upload one question related to time division, so I will upload that one before midterm, and also
Yes.
try to upload the solution for tutorial 1. Zania asked me to do that, so during this weekend I will settle all these things. And the midterm will be some questions similar to tutorial, and we will have for sure some scenario, all right, design, especially for design. If we have some bandwidth, if we have a signal, we need to do multiplexing, we need to link with some circuit switch or packet switch. So it's some design, which is, I really feel that's I mean, such type of question is really important to you guys in order to give you the opportunity to think how to solve some complex engineering problem. All right, guys. So thank you for today's class, for attending this class, and we will meet each other by next week.
Thank you, sir. Have a nice weekend.
All right, you two guys. Thank you very much. Okay, bye-bye.